talk about with this justification. That only tells me the question, when should you use it? Then it says why. Okay, you've got to make sure that you are justifying your answer, and that's awesome. You are correct. We use it. Well, when I have my stuff on here. Okay. Okay. So when there is an even root, we use plus and minus. Why? That's when. Now tell me why.
Because any number of negative times itself that's even is positive.
Very good. Okay, let's word that a little bit differently.
Yeah, I don't know how to word it.
So she's saying that if we do like -8 times -8, that's always going to be a positive, right? If we did negative, 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 4 of them, that's still going to be positive, right? If we do 6 of them, that's still going to be positive. So how could we word that in a nice way? Anybody got any suggestion?
Because any number times negative equals positive?
Well, there you go. That's a good one. Okay. This is due to multiplying an even amount of negatives will always become a positive. Okay. Math workshop done. Woohoo!
Whoa!
Yep. Now remember, this semester I told you we were going to do less math workshop.
And more ACT.
And more ACT. There you go. Juniors, you got March 20th. It's going to be your free ACT here at school, okay? March 20th. All right, so we're going to do ACT 16 through 18 today.
Don't we need a new paper folder?
Yeah, get it right in. Jasmine or no, we all hand one over to Aaron for me.
There you go.
I'm just a calculator.
Why are you
I have to hand one over to Aaron for me.
I don't know.
Stop, you got total comparison.
No, Ethan. How long? 20 years ago.
Don't act like you don't remember them.
That's older than like how long y'all been alive. Yes.
Excuse me? Are you assuming my age with legend?
Yeah, you can just come in the low block. You need this. Don't let your
No. Here we go. We got 3 problems. One day we're not doing anything. Oh, that's funny. That's cute. One day we don't do anything.
No, I meant like if we're like towards the end of the year, like in like the last 2 days.
We'll see. So we got 3 questions,
I'll
right?
come for that.
3 questions. And that means how many minutes do we get?
3, 4.
What?
3 minutes. 3 minutes. Don't go, don't go, don't go. Go. 3 minutes. Alright, guys, go ahead and put that in a safe spot. We'll go over on Monday. ACT prep is tomorrow from 8 to 12, by the way.
8 to 12.
8 to 12. Yep, be here at, in the library at 8. Calculators. Huh? The ACT? Oh, Chapter 7 test, yes, it's Tuesday, yes. The ACT is next Saturday. Alright, so let's go. Let's do something real quick. Got a real short Chapter 7 test. It's not going to be anything crazy. Okay? Should be pretty easy. But, before we do that,
Logs.
let me stretch you out a little bit more.
Yay.
Yay! No, not really. Hopefully it won't stress you out. Hopefully this will help more than stress. But I know project. Yeah.
What is that? A project. What time we done
Oh man.
Okay.
I don't know what this is.
So this is supposed to be a pretty easy project. It's not difficult. So let's talk about a few things. Here we go. The very first thing is, this is your directions, right here in front. The back of it is your rubric. Telling you exactly how I'm going to grade you. Now let's look at your rubric. You ready? Okay, the very first thing, you get 20 whole points just for following directions, okay? You get 5 points to make sure that you have all of your information labeled and on your poster board, okay? As long as everything's on a poster board, you get 5 points just for that, okay? So then you get another 5 points just for putting your title nice and pretty somewhere at the top of your poster board, okay?
5 out of 100, we're going to do it.
We'll go 10 out of 100 so far. Poster board and then your title.
Well,
Then you get another 5 points if you label each function. So in other words, I don't need to guess which function is which. Okay, so if you look on the front, we are doing a square root function, we are doing a cube root function, and we are doing a fourth root function. So all you gotta do is label those, okay? Put that over. Hey. Alright, then last thing on 20 points is characteristics near each function. So for example, what do you think? Alright, so you're doing your square root function, right? And you're going to need to graph it and tell me some other things. Everything needs to be right underneath that square root function or right beside that square root function. Does that make sense to everybody? They don't need to be like all different places all over the poster board. All good so far? All right, that's 20 whole points just for that. All right, next little section, square root functions. You get 5 points for giving me a table of values, actually putting it on there, and for putting a graph on a piece of graph paper and making it nice and neat and pretty. You can do it on a regular graph paper, or you can do it on the computer, print it out, and cut and paste it on your poster board.
How big would the graph be?
I need to be able to see it without a microscope. And it needs to fit on your poster board.
It's big, like one of the ones that I've been doing like this. Type deal.
Yeah, or just a regular piece of graph paper and you can just like cut it out off of there. That's fine. All right, where do you get to get a table of values from?
Your table from your calculator.
Oh, your calculator,
Job
right?
saver.
Okay. All right, and then you get 5 points for telling me the domain. You get 5 points for telling me the range. And you get 5 points for giving me the end behavior. Now I want you to put this to the side for a minute. That's 20 whole points, right? 40 whole points all together. And I want you to turn to 6.3 notes. I think it was like page 9 or 11, something like that. Turn to 6.3 notes, like page 9 or 11. I can't remember what page it was. 6.3 notes. Okay. What page is that, 11? 11. Page 11, okay, let's go. Page 11.
Okay.
Right there. Now you got your rubric handy? What did you have to do with the square root function? The very first thing? Go back on your rubric. It was the very first thing about a square root function. Table of values, right? And do what?
Graph paper.
Do you see a graph somewhere on that 6.3 notes?
Yes.
Okay. You gotta have But when you graph it, you can't just do this. This is what some of you are doing on your notes and your homeworks and stuff. What's wrong with this?
Points.
There's no points there, okay? You've got to give me all the points that your table of values has on there. Does that make sense so far? Look on your rubric. What else were you supposed to tell me about a square root function?
Intercepts.
Domain, right? When we did 6.3 notes, you should have written in the domain already there. All right, what else was on that rubric that you were supposed to tell me? Range. When we did 6.3 notes, you should have written in the range right there. I mean, it should all be right there in front of you, right? So far, I've like literally given you 40 points so far. What was the next thing you were supposed to give me for square root?
In behavior.
In behavior. Look at that little box right there on 6.3 notes. Do you see the in behavior written in there? Do you remember doing that? As x goes to 0, x goes to 0, as f of x goes to 0, all that stuff. It's written all right there for you. Good so far? That's 40 points I've basically just given you. All right? Let's look at the rubric. What's the next thing after square root function?
Cube root.
Have we ever graphed a cube root function? No, but what do you have right in front of you, or should have right in front of you? Calculator. You should have it, and then you just connect all the points and make it look nice and neat and pretty, okay? Domain and range and in behavior of cube root. What's the next one? Fourth root. Well, we have never graphed a fourth root, but you got a calculator right in front of you, okay? And then do domain and range and in behavior. Then there are 20 points, finally, about 2 questions. 10 points for question 1. 10 points for question 2. Well, let's read about question 1 and question 2 on the front. And way down there at the bottom, requirement 4, compare and contrast. Ooh, what do those 2 words mean? Compare tells me how they're similar. Contrast tells me how they're different. If you didn't know that, you might want to write that down, okay? Compare means how they're similar. Contrast means how they're different. So what are you going to tell me that they are similar first on question 1? What's that? Compare and contrast what?
The domain and range of an even root and odd root function.
Beautiful. So you're going to tell me how the domain and range of an even and odd root function are similar. And you're going to tell me how the domain and range of an even and odd root function are different. Does that make sense to everybody so far? All right, next question. Tell me what?
Compare and contrast even in behavior and even on odd root.
The in behavior. There you go. So you're going to tell me how they're the same, and you're going to tell me how their in behaviors are different. You got it good?
When's this due?
We're not there yet.
Oh.
Now, every single bit of this should be where, when you turn it in, on a poster board. Now, there's 2 last things. Ready? First thing is the last thing. One of the last things we need to talk about is you get 1 chance to turn this in for a rough draft for me to kind of quote unquote grade it and tell you what you need to fix before the due date. Okay, I'm getting to the due date. Okay, you get 1 chance to turn it in before the due date, and I will kind of tell you what you need to tweak so that you can get as high as a grade as possible. Does that make sense to everybody so far? The due date is an easy one. It's February 14th, right? Okay, February 14th is the due date.
So this poster has a date for Valentine's Day and
Aww.
Dang,
Wait,
that's
what is
so
that?
Real
sad.
deep, actually.
What does this mean?
He says to this project has a date, but he doesn't. Valentine's Day.
I get it.
That's hilarious. That was pretty awesome, Ethan, actually. That's pretty awesome. All right, last, yes, ma'am.
Okay, so you said that we can turn like a rough draft, but like, does a rough draft, like, can that be on just like?
Yeah, it doesn't have to be on the actual poster board. Yeah, that's a really good question. The rough draft is just a rough draft. Turn it in and like, let me check and tweak some things for you. That way you can try to get a good grade. Okay? All right, last thing. Here we go. Very last thing is the rubric. The rubric must be either glued or taped to the back of your poster board, okay? Your rubric must be either glued or taped to the back of your poster board. Hopefully this should be a very easy grade, okay? Hopefully. All right, put this in a safe spot somewhere, and that's your project. What they
I'm
can
a
do.
watercolor.
Whoa, I'm sorry, I just walked around with you doing that. All right.
Super adhesive.
Oh my gosh.
No, you use rubber cement.
Plug seal.
There you go. Solid.
Alright, so now we've got what, 6 problems to do?
I guess.
6 problems, and that's it. And then we are going to review on Monday and type on
Hey, I ain't going in.
Hey, I got it today. Don't worry about it.
Alright, Ethan, here we go. Ready?
Coming.
How did yesterday go? We are okay? Anybody lost about yesterday? It should be pretty easy stuff. Okay. Couple of us have not turned in our homework yet. So if that is you, that bottom page will say all right. What was that? Page 2 or 3? Sorry, so 2? 2. Page 2. Make sure that you have turned in page 2, that bottom half of your homework. I'm going to give those back to you. I've already graded them for you. Yes, they're already in I know. So I will give those back to you if you did turn them in. So let's look at this guy. Chapter 7 is not difficult at all until we get to the very end.
Oh.
And it's not that it gets difficult. It's just that y'all forget to do what to do where and what to do when. Does that make sense to everybody? Okay, so let's start by understanding what's going on 1 through 4. 1 through 4, there's only one logarithm. Are you okay with that so far? But look at 5, 6, 7, and 8. How many logarithms do you see on 5, 6, 7, and 8? 2 logarithms. Everybody see the difference between the two of them?
What does log mean?
Huh?
What does log mean?
I don't know if algorithm is.
Yep.
All right, here we go. So, since we only have one logarithm, we're going to rewrite this with our base and our power. What's our base for number 1? 36. What's our power? 3/2. Very good. Whatever it equals is your power. And then, what does it equal now? X. And it does say solve. It does say evaluate. So you got to keep going. This exponent is a fraction, which means that you have a radical when you have a fraction, right? What are you dividing by? What are you dividing by? 2 is what you're dividing by. Right here, you're dividing by 2. So it's a square root of 36 cubed. And then you take your handy dandy calculator and you type in the square root of 36 cubed. And what do you get? So what do I write as my answer?
No log of 30.
Danielle? Y plus and minus because it's even. Very good. So we're going to write x equals plus and minus 216. There you go.
Can we just, like, hit the 36 up arrow, parentheses, 3 divided by 2, and give us the same answer?
Yes, as long as you type it in correctly. Yes. All right, number 2, how many logarithms do you have? 1. So that's why we're going to do it this way, okay? We only have one logarithm. And I want you to keep this in your head. That way on Wednesday, when we start the rest of it, and we start piling on all these rules, you'll know when to do what when, okay? So you have your base of 6. Whatever it equals is your power. And then now it's going to equal 216. This is what the bottom half of your homework was. This is what 7.2 was. In order to figure out what that exponent is, you have to have the same base, right? So 6 to what power is 216? 3. So you got 6 to the 3x equals 6 to the 3. And now 3x equals 3 and x equals 1. You okay so far?
Yes.
All right. Number 3, same thing. You only have one logarithm, so that's why we're going to do it this way.
Wait,
You
what
get
do you have to do?
on the bottom part. We're getting there. We got a base of 3. Whatever it equals is your exponent. And then now it's going to equal 243. Is there 3 to some power that gives me 243? 5. Very good. So you've got 3 to the x minus 4 equals 3 to the 5. And now x minus 4 equals 5. And to solve, you would add the 4. So x equals 9.
How would you check this up?
You would plug it back in. So 9 minus 4 would be 5, right? And so then you would just redo it. You would say 3 to the 5th equals 243, and that is straight. 3 to the 5th is 243.
Wait, how do you plug log 3, 243 into our
You
calculator?
can't yet. Because when you hit, there is a way. When you hit that log button on the side, it's going to give you log base 10, and all of these are log base 3, which is why we have to go through all this mess, because our calculator won't do it for us yet.
Well, I want to do it yet.
Because I haven't showed you how to do it yet.
Huh?
Number 4. How many logarithms are there? 1. So you got your base of 4. Whatever it equals is your exponent. And then it equals 4x minus 20. And this is like your checkpoint. It looks a little different, and so y'all like stop and you freak out because you can't work it any other way. Yes, you can. What could you do to solve for x? Because x is not an exponent. It's right here like a normal one. Not add the 20 first. Remember order of operations.
Solve x for everybody.
Exponents first. You got 4 to the 5th first.
That's a big number.
That's a big number,
Yeah,
yeah.
but I was like, can we just like take that?
1024. Very good. And then I can add the 20 and get 1044. Then divide by 4 and you get 261. Yeah, that's right. How are we doing? We okay? Yeah? Alright, let's go to the last 4. Here you go. Bottom 4. Now, how many logarithms are on the bottom section? 2. Alright, now here's what I want you to understand. Do the logarithms have the same base? Are they both base 2? Yes. That's why we can do this. They are both base 2. So, just like the exponents, if they have the same log on both sides, then you can set their pieces equal. So you can set x squared minus 4 equal to 3x. Now, since I have an exponent of square, then what would I do to be able to solve for this?
Square root. Oh, just kidding.
I would need to factor it. Very good. I wouldn't want a square root because of that x. If that x wasn't there, then yes. So we do want to factor. And when we factor, we want to keep that x squared positive. So we're going to move that 3x to the other side. And now it's equal to 0, sorry. What's wrong?
Well, I think 5 squares though. What, you need
What?
difference of squares?
This one? Yeah, you could do difference of squares, but then you're still going to have this guy you wouldn't be able to do anything with. So if this was equal to 0 instead of 3x, yeah, you'd want to do that. All right, what's the factors of 4, negative 4?
X plus 4 and x minus 1.
All the way around. Minus 4 and plus 1. Very good. That would give you the negative 3. All right, so what are your 2 answers? Yep. Perfect. Very good. Very good, very good. All right, number 6. Do you have a logarithm on both sides? Does it have the same base? Yes. Everybody with me? Off your phones? So you've got x squared minus 15 equals 2x. The only reason you can set them equal is because they have the same logs. All right, so we want to keep that x squared positive, so we're going to subtract that 2x. And now it's equal to 0.
Are we ever going to have that one?
Yes, that'll be the back half of chapter 7.
All right.
Huh?
Sweet.
All right, so what's the factors of negative 15?
Negative 5.
Very good. And so your answers are 5 and negative 3. You okay?
On the bottom one, can you divide it by negative?
The bottom one.
7.
No, not yet. Because you always want that x squared to be positive. You don't ever want him to be negative.
That's what I'm saying. Can you just divide everything by negative 1 and then get everything positive?
Oh, I mean, you could, but it's a lot easier to do it differently. Watch. Okay, number 7. 2 more. Here we go. 2 more. Do you have a log on both sides?
Yes.
Do they have the same base? Yes. So you get the x squared equals negative 6x minus 8. Now remember, you always want the x squared to stay positive because it is much easier to factor when the x squared is positive. It's not impossible to factor if it's negative. It's just easier. So that would mean I would want to move the 6 and the 8, and that just makes them positive 6 and positive 8. Don't forget your equal 0 part, okay? Because if it doesn't equal 0, then you can't take it further. So what is that, 4 and 2?
This is the last one we're doing, right?
Yep, that's it. And we'll do a checkpoint. Yep. Just because I want you to learn how to do it before we take the test. I'm trying to help you. Alright, are we okay for real so far?
Yes.
Anybody lost?
Yeah.
Okay, alright, same thing on number 8. They have a log on both sides, and they're both the same base. So you got 3x plus 8 is equal to x squared plus x. And you want your x squared to stay positive, so you're going to move the 3x, and you're going to move the 8, okay? So that'll be x squared minus 2x minus 8. 1 minus 3 is negative 2. And then move the 8 over. Alright, what's my factors?
Negative 1, 2, and negative.
Alright, so that gives me positive 4 and negative 2. That's my answers. Are we okay? Yeah? Okay. And like I said, it's not the end of chapter 7 is hard, it's just that we throw all these different ways at you, and it's just hard to remember when to do what. That's the whole thing, okay? Alright.
Is there any other day in here that you don't do?
My sister is like that. Every time.
What course day? What course day, Matthew?
We watched Moana one day.
Did it too, sorry.
Is that in Chris's book?
Alright, let's see. 3, 4, 5. You're showing it.
That's right. If we turn it in early, we get bonus points. I don't mean this, I meant the project.
Did I give you one? Yes, okay. Aaron, did you get one of those? Alright, the bottom section down there does say to evaluate, so give me the actual number, okay?